All right, so we're going to look at vocabulary. We have asymptote, point of inflection, vertex, axis of symmetry, convex, and concave. An aspect of a function that always goes up and stays flat but never goes down is going to be convex. An aspect of a function that always goes down and stays flat but never goes up, this is going to be concave. So it's convex, concave. This refers to the highest or lowest point on a graph. This is going to be the vertex. This point on a graph of a function where the function of concavity changes. For example, if a function changes from being concave upward to concave downward, or vice versa, there is a point of inflection where this change occurs. This is just point of inflection. And then it says an imaginary line through a graph that divides the graph into two mirror image halves, or the x value of the vertex. This is going to be the axis of symmetry. And it says an imaginary line or curve of a graph that approaches or extends to one or more directions but never actually crosses or touches. The line represents a gap in the domain or range of a relationship. This is the asymptote. We're looking at a function that is a square root function. If we had to determine the function, it would be the square root of -3 minus 1. So let's talk about the x-intercept. In this case, the x-intercept is going to be at -2, 0. The point of inflection, there is none. So remember, the point of inflection is where the graph changes direction. The vertex, there is none. And the axis of symmetry, there is none. We're going to look at number 8. So this is a parabola, so it's probably a quadratic function. I'm going to label the vertex first, and the vertex is going to be 2, -1. And then I'm also going to label my x-intercepts. You can have more than one x-intercept. So my x-intercepts are going to be 1, 0, and 3, 0. Let's go ahead and answer the questions. Okay, so the x-intercept, again, there's 2 of them, 1, 0, and 3, 0. Point of inflection, there's none. My vertex was 2, -1. And my axis of symmetry is what we want to concentrate on. So on this one, it says the x value of the vertex is going to be the x equals 2. So if I draw this out, my axis of symmetry is at x equals 2. And I'll illustrate that by highlighting it. So it's right here. Axis of symmetry. That's where the x equals 2 comes from. We're looking for the x-intercept, point of inflection, vertex, and axis of symmetry. So let's go ahead and look at this. I think the axis of symmetry is very apparent here because we give you a dashed line. So I'm going to label my x-intercepts at 11, 0, and -3, 0. My vertex is going to be 4, -7. And my axis of symmetry, again, is a dashed line, so this is x equals 4. Remember, it's the x value of the vertex. So my intercepts are going to be 2 of them, -3, 0, and 11, 0. The point of inflection, there's not a point of inflection. My vertex is going to be 4, -7, and my axis of symmetry is x equals 4. Statements are true. This is a relation, but it's not a function. It's not a function because it doesn't pass the vertical line test. For every vertical line I have, my graph crosses it once. So this is not a function. Number 11, a relation. This is true. A function, it is a function. Because when we do the vertical line test, it only touches each vertical line once. Okay, and then the last one, number 12, it is a relation. So let's see what else. Is it a function? Yes, because for every vertical line test, it only touches the vertical line once, so it passes. So it is a relation and a function. Meters of a basket suspended on a spring to a table below is dependent on the number of steel bearings in the basket. The function representing this relationship is dm equals 9 minus 3m, where dm represents the distance in meters and m represents the number of steel bearings in the basket. Write the set that represents the evaluation of the function of dm when m equals 0, 1, 2, and 3. So this means that we're looking for the range. So we're going to set this up where x equals each of the values in the set so that we can state our range. Okay, so 9 minus 3 times 0 is going to be 9. 9 minus 3 times 1. So it's 3 times 1 is 3. 9 minus 3 is 6. And then 9 minus 3 times 2. So 3 times 2 is 6. So 9 minus 6 is 3. And then where x is 3, 9 minus 3 times 3. 3 times 3 is 9. So 9 minus 9 is 0. So our range is going to be 91630. Produces and sells smartphones. The profits in dollars from selling X smartphones is modeled by the function P of X equals negative 0.1 x squared plus 30x minus 1000, where X is the number of smartphones sold. Write the set that represents the evaluation of the function P of X when X equals 10, 20, 30, or 40. So we're looking for the range. Okay, so our domain is 10, 20, 30, 40. So we're going to substitute x equals 10 into the equation. When I rewrite the equation, remember I'm typing it out the way you would enter it into the calculator. So it'd be negative 0.1 x squared plus 30x minus 1000. And so when we evaluate that, we get negative 701. At x equals 20, when it's evaluated, it's at negative 404. X equals 30, the evaluation is negative 109. And when x equals 40, our evaluation is at 184. So that makes our range equal to, and we're just going to list the numbers the way it came out, 701, negative 404, negative 109, and 184. Represents a function. What is the value of f of negative 3? So remember, what's in the parentheses is x. So x equals negative 3. So negative 3 is right here. We go down. Our value of f of negative 3 is going to equal 2. And then this number 16, what is the value when f of x equals 4? That should be a question mark. F of x equals 4. This means that y is equal to 4. So you're looking for y on the y-axis. 1, 2, 3, 4. So we have two values. We have one at 3. We have one at 5. So we want to give both values or as an ordered pair. So it's going to be, again, right here, right, because this is at 4. So it's going to be x equals 3, x equals 5. Or it can be listed as x equals 3, comma 5. Well, that means the same thing.